So people lately have moved more towards what we call it agile model, right? There is a word called agile, right? Agile is an umbrella word, and it's one of the software development methodology. So what I'm talking right now when I say waterfall, waterfall is one of the software development methodology, right? So waterfall is one of them and very traditional. But nowadays people talk more about agile, and agile is an umbrella word. Under agile, somebody calls Scrum. Somebody calls, Kanban approach, right? Somebody talks about spiral, right? There are different ways you do. Somebody also calls pair programming. All these are different software development model, which is non-traditional, which is unconventional. Waterfall is very conventional. People have been using it for a long. People started realizing the problem with the waterfall. The good thing about agile is, in general, whether you follow Scrum model or you follow Kanban or spiral, whatever you call it, the goal is every few weeks you build a software that can be seen by users and maybe used by users, and then you continuously evolve and add more and more and more features. So it's like you build. If I asked you to construct a house, you tell your vendor that, hey, give me 1 bedroom in next 2 weeks or next 4 weeks, and then I will start living. That's okay. I don't have a restroom. I'll go and use public restroom area. You add a bathroom after 2 weeks. That way, I know I'm paying you money, but the benefit is I don't have to rent a house. Now I can start living immediately because the house is almost ready, but not fully ready. But it is ready enough that I can start using it. And then you keep adding more room on top of it, and then you finish it. That way, I can very closely look at it. I can start using it in many cases, and I have a better say. Suppose I realize that, you know what, I don't have enough space here. Maybe I should not put my washer and dryer on the top floor. I'll put it in the bottom, in the living room, in the main floor, right? And you can make the change. It's not too late because, yeah, at a high level you designed it, but you are building it in phases. The whole idea is to build in the phases. Build the software in phases. And when I say phase, does not mean that requirement and all. In each phase, you still do the same thing. What you did in waterfall is that rather than building in one big chunk, now you're building it in smaller pieces. First you build this, then this piece, then this piece, this piece, this piece, this piece, right? So 1, 2, 3, 4, 5, 6, 7. Now you are building it, the whole software, in 7 pieces, and you prioritize it. You say, okay, I want this to be done first. Then you start on this. Then you realize, you know what? I forget about bathroom. Let's first put a living room or a deck on the backyard so that I can enjoy my sun in the winter. So you may put number 5 in priority, and then you can still adjust it. That is why it's called agile, because you can adjust adjust how you want to build it or what you want to build it type. What do you want to build first? What do you want to build last? You can adjust the pieces. You get to see the software literally every day, and every few weeks you can start using the software. So Scrum is one of the very popular model nowadays. So what you really do is you take a four week approach, 4 weeks, and we call it a sprint. You know how you run marathon or 4x100 relay race, right? So you have this 100 meter, this is another 100 meter, this is another 100 meter, and finally this is 100 meter. You run 100 meter here, then you run next, and then run next, like this. Similarly, the whole software development of like 1 year may be split into smaller pieces. You say, okay, I will build this in 24 months, 24 cycles. So every 2 weeks. So you whole 1 year project is split into 1 year project is split into 24 sprints, and each sprint is 2 weeks. Some people keep it 4-week sprint. That means you will have 12 sprints. Within 12 sprints, their whole software has to be completely built. But within each sprint, every 2 weeks or 3 weeks or 4 weeks, whatever is your sprint definition, right? You have a, what we call it, within. Now I'm looking a little deeper into Scrum at a high level, right? You look into your complete backlog. Your complete work is called backlog. and you look at your backlog and you say, okay, you know what? I'll take a small pile out of it, small piece of work, small set of work. I'll take a small, a set of tasks here, based on my priority, and do it in sprint 2, sprint 1. Once you're done, you realize you have to make some changes. You go back and update a couple of your tasks. The tasks are called stories, right? So these stories, a backlog is nothing but list of all the stories you are going to do that, all the tasks you are going to do that as part of the software development. You pick set of stories, do it in 2 weeks. Then you take next set of stories, build it in sprint 2. You pick next set of stories, build in sprint 3. And this is agile because now you have a flexibility. You can change the priority and say, you know what, 4th sprint, I will do something. And the story that I was thinking for 2nd sprint, I'll put it in 6th sprint because I don't need it immediately. Now you're more flexible. You have divided the whole task into smaller pieces. You're able to handle it better. Okay. This is what we call it SCRUM. A couple of words you want to remember it, but we call it backlog. Backlog is a list of all the tasks you're going to do that. A sprint is a set of tasks. You're going to do that in 2 weeks or 3 weeks or 4 weeks. They ask you like, okay, what is the sprint? How long is your sprint? You can say 3 weeks, or 4 weeks. It depends on whatever is, company decides. The best part of Scrum is you see a software tangible, an output at the end of a sprint, because the goal is to deliver a usable piece of software at the end of 2 weeks. Even if it is a very small feature, right? A very small task. Just create a file for Citibank. You want to do it in the sprint. You do it so well that you can actually use this piece now. I'll pause it here. Any question?
Yes, I mean, do we get these questions in data science roles as well, or is this like software developer role questions?
So basically, this is not really, whether you should look at the data science. Let me quickly talk about one more thing. Okay. Look at a developer part. So when you do the software development, any software for that matter, right? You have 3 pieces, and I drew the picture. You write what we call it user interface, right? You create screens where you can go and click. Usually you use here HTML plus JavaScript plus cascading style sheet. This is basic web development. Anytime you use it. And nowadays, on top of it, people use Angular or React, which is nothing but JavaScript based framework. Okay. And then this UI pull the data or send the data to what we call it APIs or web services. I don't know if you guys know web services, but think of web services, and I'll quickly talk about web versus web services, right? And then finally, anytime, any system, you store the data in the database, right? Every IT system we build has this same structure. Database can be SQL Server. Database can be Oracle. Database can be MongoDB nowadays, right? MongoDB or DocumentDB. All this is what we call it. These two are like pretty much a relational data. And MongoDB or DocumentDB, Cassandra, or call it NoSQL database. And for web services, you use either Node.js, or you can use C#. You can use Python with Django and all this, or Java and all. This is what is going on right now in the industry at a high level. Web services, you use some of these like Node.js. Node.js is JavaScript based. So if you know the whole idea of Node.js is, hey, you're already using JavaScript on the UI development. Why not use the same JavaScript on the API development to pull the data from database and show it to the UI, or capture the data? Suppose I enter my first name, last name, social security number, capture the data, send it to the web services. Web service will push it to the database. Why do we do it in 3 layers? Because most of the business logic lies here. Suppose we want to make some changes here. We don't have to change the UI. We don't have to change in the database. So this 3 layer is meant to do decoupling. Now the data science comes into database side. The 2 things happen. One is apart from capturing the data from in the UI, using the web services, passing the data to the database and storing in the database, and then in future retrieve it and show it in the UI. This is a typical model. On top of it, you also want to pull some direct reports from the database. People use a lot of reporting for which you don't need any API. You write some script and you pull a report directly from database. You also sometimes extract this and do data analysis, right? Data analysis. And third thing is, nowadays people are started doing is what we call it predictive analysis, right? Rather than predict. So rather than just simply analyzing the data, looking at the pattern, you look at the pattern and start predicting also. You say that, okay, based on this, if I look at your history of the money you spent on your credit card, I can safely predict that in certain months, you do certain more this type of expenses. I can predict that, based on that, I can send you some coupons. I know you're going to buy clothes. I know you're going to buy some, shoes or sandals, right? What we call it prediction. So data analysis is more about looking at the pattern of data. And next step is what we call it prediction. Now that I know your pattern, I will be able to predict it. And then this is where you use some of the machine learning models to look at the data. And there are some algorithms which you use it to look at the data and make a prediction. One of the prediction is, take an example. In algebra, you may have read it, right? What we call a linear regression. So this is an x-axis, this is a y-axis. These are the data points, right? These data points, you are saying for given, suppose this is your axis, suppose this is your, temperature, and this is your humidity, for example, right? So looking at temperature and humidity, you can see different data points. My goal is to find a pattern. How do you find a pattern? What we call it linear regression is one of the models. So find a line, like in algebra, you must have read it, y equal to mx plus c. Your goal is to find a line that touches most of these points, or the distance from this point to this straight line is minimal, right? That means this line is going, this blue line is covering most of the data points. That you have to find an equation. And once you find the equation, like value of m and c, then it's easy, because for given x, I will be able to say, and this is your prediction. This is all linear regression is all about. It's a straight algebra application of y equal to mx plus c. As simple as that. The goal is to find the value of m, the slope here, the slope of this. That's why if you know math, a little bit of stat, it's much easier to understand most of these algorithms. But anyway, we'll talk about it later. The goal is, as I was telling you, when you do the data science, you're mostly looking at the database, not really UI. You're looking at the data elements. You're writing queries to retrieve the data. So you write queries, right? Then you are building some sort of model. You do the data analysis. Data analysis is one of the, right? And then, you are doing some sort of reporting, either Power BI and or Seaborn library in Python and all that part. So you need to know one programming language. You need to know one database. So, and you need to know, some of these, Python libraries like Mongo, NumPy, Pandas, and all. A lot of libraries or built on top of Python to help you do this type of data analysis. So once you know Python, then you will be able to learn NumPy, Pandas, and all, and then you will be able to learn one of the database a little bit, so that you can write queries. Because if you can't pull the data, then you will not be able to do any data analysis. Where data is stored either in Excel, Microsoft Excel, or in some text file, what we call it structured versus non-structured data and all that part. Did I answer your question?
Yes.
I know I went, too far, I guess.
Yeah, but that's okay. Yeah. It answers.
Right? Okay. How about you, Deepali?
So when we work in this and when we do analysis and reporting, are we still answering to our managers and all in terms of sprint or no?
Yes. Yes. So in the sprint, they decide and say, okay, you know what, we need to build this type of report. We need to do this type of data analysis. We need to do some preliminary data analysis, and understand,
They have
find some pattern.
okay.
Yes. So they may tell you, set a goal saying, build this model in this sprint, and then, or you do data cleaning in this sprint, because this whole data pipeline has data gathering, data cleaning, what we call it, data massaging. Then you have to do some analysis. Then you have to do modeling. Then you finally, test your model. So this, everything revolves around model. And when I say model, finding the right algorithm, like should I use linear regression? Should I use, yeah, exactly, right? And finding the right type of analysis model, and then train your model so that once you deploy this model on millions of records, your model gives you right prediction.